So good, what morning, afternoon? This is afternoon. Good afternoon, everyone, and welcome to today's class. We were dealing with Newton laws of motion, and we were dealing with connected bodies. Well, we have seen some cases of connected bodies. One of these cases is going to come in your exam. One of these, and I hope you remember these cases. Remember this? We had seen the case where a block was kept on a wedge. We saw what should be the value of F so that it goes up, so that it comes down, so that it remains at rest. Do you remember this? Now we will come to bodies kept in contact, and these are the most famous type of questions that I have seen in your NEET, and they are pretty straightforward. So I'm not going to give you entire theory on how to do it. I'll just show you the case, and I'll tell you how it is done. And if you understand the logic behind it, you would be able to do it. So the heading is motion of bodies in contact. Motion of bodies in contact. So the two bodies or two or three bodies are going to be kept in contact. And I will straight away show you the snapshot rather than taking any time, because there is no point of understanding the entire process. It will not serve any purpose for you. So basically, just have to find out the acceleration, you just have to find out the force, and you can get the concept right away. See, here what do I have? I have two blocks of mass M1 and M2. Do you see these two blocks? Mass M1 and M2. They are kept in contact with each other. Yes or no? And I am applying a force F. This is a push. I'm pushing the body. Now what is going to happen? Just understand the theory behind it, that these two blocks are going to move together. Yes or no? These two blocks are going to move together. Yes or no? Do we understand this? They are going to move together with the same acceleration, because they cannot have different acceleration. If they have different acceleration, that means they are not in contact. Two bodies are in contact, they would have the same acceleration. Yes or no? So they have the same acceleration. So how do you find the acceleration of this? The acceleration of this system will be simply equal to total force divided by total mass. Do we understand this? The acceleration of these two bodies would be same. If you want to write the entire thing, you can write the entire thing. Otherwise, you can only draw this diagram. You don't have to draw the free body diagram, beta, because you will not get so much of time in the examination hall. So you may not draw the free body diagram. What they are going to ask you are only two things. One thing is the acceleration of the system or acceleration of any of the blocks. They are same. It is F upon m plus m2. In rare cases, they might ask you the value of this F. What is this F, bacha? Can anyone tell me what is this F that you see here?
Friction.
Friction has not come. The name of the chapter is not friction at all. Friction is not there.
Force.
No. Yes?
Force.
Which force? This force, but which force?
Frictional force.
Applied force, sir.
Then what is this capital F? If you look at the original diagram, this is the original diagram. This is the original diagram. F is the applied force. Which F? This F is the applied force. You see here two more small f's. They've used us. They probably used the wrong alphabet. Let me call this as R. What is this R? Just to make it different from F. What is this R?
Reaction force.
From where this reaction force is coming? These
M2.
two, yeah, these two bodies are kept in contact, so they are both pushing each other. M1 is pushing M2 forward. M1 is pushing M2 forward, and M2 is pushing M1 backwards. Do we understand this? And that is why this force is coming. This is the reaction force between the two blocks. Do we understand this? So there are only two things that they are going to ask. Either they will ask you the acceleration of the two blocks, or they might ask you the force between the two blocks, or the reaction force between the two blocks, which is given by this R. So what is the value of this R? To get the value of this R, you will have to draw the free body diagram, else you will not be able to get this. So therefore, there's the chance of them asking this force is very less. The chances of them to be asking this force is very less. This R will be equal to M2 multiplied by M. Remember, the force is applied on block M1. Forget about this R. No one is going to ask you this R. Do you understand the free body diagram of these two blocks? So you can remember this R in this fashion. M2 into F divided by M2 plus F. Why I'm not asking you to draw the free body diagram? Because you may not get so much of time to draw the free body diagram. And in most of the cases, this is not going to be asked from you. What they are going to be concentrating on is the force, is the acceleration of these two systems. Do we understand this? Okay. So here, force was applied on block M1. The acceleration of the blocks is F divided by M1 plus M2. And the value of reaction force is M2 divided by M1 plus M2 multiplied by F. Remember, force was applied on block M1. Do we understand this? Then we can come to the second case. Have you noted this down? Now, in the second case, as you will see, the case has been reversed. Force, instead of being applied on M1, the force is now applied on M2. The force is applied on M2. So you can see the free body diagrams have changed. This is the free body diagram of M1, and this is the free body diagram of M2. Here also the reaction force between the two blocks is R. There is no need for you to understand this equation. Here also you see the acceleration of the two blocks is F upon M1 plus M2. Do we see this? Because both the blocks are going to move together. Do we understand this? The only thing that has changed is the value of this R. It now becomes M1 divided by M1 plus M2 multiplied by F. Okay. Do we understand what is happening here? Again, why I'm not telling you to draw the free body diagram? Because you will not get enough time to do that. Right? Shall I move on to the next case? Now, in the next case, instead of 2 bodies, we have 3. And again, oops, what has happened here? Just move. Instead of 2 bodies, I have 3. And there is this force F applied on the 3 bodies together. Now remember, what they are going to ask you, if they want to make a difficult question, they can ask you F1, R1 and R2 as well. But in most cases, they are going to ask you what is the acceleration of this system. So what is the acceleration of this system? Do we see? It is total force divided by total mass. Do we see this? Acceleration will be F divided by M1 plus M2 plus M3. Do we understand this? Now, if you see the free body diagrams of block A, let me explain. There is a force coming from backwards. This is reaction R1. This is applied by the block 2. The same reaction will be applied by block 1. So it is here. Again, block 3 will apply. Okay. Again, the block 3 will apply R2 here. Block 2 will apply R2 here. These are action and reaction forces. And therefore, we get the free body diagram like this. Again, you are not going to ask this. They are not going to ask this. They are probably going to ask you only the acceleration of the 2 blocks. But you can remember this, and I will tell you the trick to remember this. The trick is very simple. To find the value of F1, it's on the middle block basically. So what you do is M2 plus M3, the further 2 blocks from the force divided by the total mass. To find the value of F2, which is the force on this block, you just take this block and divide it by the total mass. That is how you can understand or remember this. The last block is only moving by the force coming from the previous block. So it is that block divided by the total mass. When you remember this thing, you can find out the answer for any case. Do we understand the trick? Last block, force on the last block is mass divided by the total mass. Okay, do we understand this? Now see, have you noted it down? Now see, you can apply.
Sir, can you explain again?
See beta, I'm just telling you how to remember it. I'm just telling you how to remember it. If I have to explain it, I will have to explain the free body diagrams. If I just explain the free body diagrams, if you want to do it with your own hands, this is how you will do this. If I want to explain it clearly, this block is moving like this. What is the net force in this direction? This is the force in this direction, F. This is the force coming from the opposite block. So F minus F1 is equal to M1A. This block is also moving in this direction. So this force minus this force will be M2A. Free body diagram. This block is also moving in the same direction. There is only one force acting on this block. So this force is equal to M3A. Do we understand how these equations are made? Now I'm just telling you what results you get, because even if you get these three equations, to get the value of F1 and F2, you will have to do more calculations. So I'm just telling you the shortest way of doing this. To find out the force on this block, M3, the last block, you divide the last block by all the three blocks. To find the force between this block and this block, you take the last two blocks and divide it by all the three blocks. Got this? So I just told you a short way of remembering it. It's not trick here, the short way of remembering it. When apply this short way here in the next one, and you will get the correct answer. See? Got this? Now, first of all, I have now changed from block 1 to block 3. You can see it here. First thing is the acceleration. Everyone understands the acceleration? Now, to get the force on this block, you just divide. Where is this block? You have to find the value of F1. You just divide this block by the total blocks. Do we get this? To get the force between these two blocks, what do? You divide the last two blocks by the total blocks. Got this? You will not get more than 3 blocks, because then that calculation becomes more tough. You will get only 2 or maximum 3 blocks. Do we understand this? Can we solve the question now? Okay. Let's see if you can use the logic and solve this question. Two blocks of mass 4 kg and 6 kg are placed in contact with each other on a frictionless surface. If we apply a force of 5 Newton on the heavier block, what is the force on the lighter block? You can also find the, first of all, tell me what will be the acceleration of this system? What will be the acceleration of this system? What will be the acceleration of this system?
1/2.
How did you get 1/2? Total force divided by total mass. You understand this?
Yes.
So it is half. Then you have to find the force on the lighter block. Can you get me the force on the lighter block? Force on the lighter mass.
Option C.
Option C, 2 newtons. There are two ways to do this. Number one, you can apply the logic. To find the force on the last block, what do you do? Find the force on the last block, F. You take the last block, divide it by the two blocks, and multiply it by the force that was applied, 5 Newton. Yes or no? This is one way to do this. You will get 2 Newton. Or the second way is, you know the acceleration multiplied by the mass. Force is equal to mass into acceleration for this block. Mass is 2, no, mass is 4. Mass is 4. Acceleration is half. You will get 2 newtons. So you can do it this way or you can do it the other way. You will end up with the same answer. Do we understand this? Anyone understands this? Can you move on to the next question? This is the next question. It comes from the previous one. In the previous problem, if a push of 5 Newton is applied on the lighter block, so instead of the heavier block, the force is now applied on the lighter block. What will be the force on the heavier block?
Option B.
4 newtons. No. 4 newtons is not correct. This is 6 Newton. This is 4 Newton. And now force is applied here, 5 Newton. I have to find the force on the heavier block, this one. How can I find it? Force on the heavier block will be 6 multiplied by 5 divided by 10. 3 Newton. Yes or no? You have to multiply this block by this force and divide it by the total. Do we understand this? If it is becoming difficult for you to understand in this way, what I'll do is we will try to do the question with drawing the free body diagram. So the next set of questions we will do by drawing the free body diagrams. Okay? Chalo. Have you done this? Okay. Then we move on to the next category. Motion of bodies attached by string. Motion of bodies attached by string. So Now I will draw this and try to make you understand how this question is actually done. So now you will have, let us say, two blocks, M1 and M2, and you will have a force pulling them. What you would be asked is to find out the acceleration of these blocks, and you have to find out the tension in the string. How will you do this? The actual way of doing this is by drawing free body diagram. So I'll draw it. To draw the free body diagram, I will start from block M1. The weight is M1G here. The normal reaction is N1. Do we understand this? Okay. Then it is pulled by a string. So T, the tension in the string. This is the free body diagram of block number 1. Do we understand this? Yes or no?
Yes, sir.
Now we'll draw the free body diagram of block number 2. M2G is here. Normal N2 is here. This force is already drawn. There will also be a tension T which is trying to pull it. This becomes the free body diagram of block 2. Do we understand this? Now, this entire system of two blocks, will they move with different accelerations or will they move with same acceleration? They're attached to each other by a string. Will they move with different accelerations or will they move with same acceleration? No one knows it? No one knows whether they will move with different acceleration or same acceleration? Think, tell me.
Same acceleration.
They will move with same acceleration. Yes or no? In which direction they will move? And also know that in which direction they are going to move,
Force.
right or left? It will move right or left?
Right.
Right. Now we can write their equations as well. So let us write their equation and see what answer is coming. I hope you can see me. So they are going to move like this towards right. Let us say the acceleration is A. So they are going to move like this. Now if I look at this equation along y-axis, then I can write this equation like this. It is not going to move along y-axis, so the normal reaction N1 will be equal to M1G. Do we understand this? Now, this entire system, oops, I hope you can see the thing. This entire system is moving towards right with an acceleration A. We see this acceleration, yes or no? The only force on this block in the right is T. So I can write the equation of this block. T is equal to M1A. Do you understand how I've written this equation? T is आगे, acceleration is आगे. So T is equal to M1A. This is the equation for this block. Now let us look at the equation for this block. It is not moving along y-axis. So I get the first answer. N2 will be equal to M2G. Do we understand this? Then I look, it has got a forward force F and it has got a backward force T and it is moving ahead. So what equation should I write? Forward force is F, backward force is T, and it is moving forward. What equation should I make here? F minus T will be equal to M2A. Do we understand this? Now, if I add these two equations, beta, if I add equation number 1 with equation number 2, what I will get is what the shortcut was all about. I will get the value of F as M1 plus M2A. So you can remember the value of this acceleration. It will always remain F upon total force upon total mass. Now, if I put the value of this A in this equation, I will get the value of T, and the value of T will be F into M1 upon M1 plus M2. That was the shortcut that I was going to tell you. I hope you understand how this is done. Yes or no? Okay, I'll give you 1 minute to note this down. Let me know once you are done, bacha.
Done, sir.
Okay. Then I can show you these two diagrams. Okay, not these two. Then I can show you this diagram, and then probably you can tell me what will be the value of acceleration in this case. Can you tell me what is the value of acceleration in this case? Fatafat. What is the value of acceleration in this case? And what will the equation be like? Anyone? Anyone? Okay, I'll give you time.
A is equals to F by M1 plus M2.
A is equal to F by M1 plus M2. That is correct. Can you also give me the value of tension? Tension between the strings. Tension in the string between them. Well done, well done. Tell me the answer for tension now. You can also look at the previous question that we have done and understand what is the difference.
T is equals to FM2 by M1 plus M2.
Very good. T is equal to Fm2 by M1 plus M2. Everyone understands this? What has happened here? Yes or no? See, that is good that you are able to understand. So this comes on your screen now, and I hope everyone can understand this and you can see this. Yes or no? Similar case. The only thing was I had changed it. Yes or no? Everyone understood this? And this is exactly same as what was coming in the contact. The only thing is when they were in contact, T was named as R because it was not tension, it was reaction. Here it is tension, therefore we call it T. Do we understand this? Now, let me make the case more difficult. Not difficult, I mean, if you just understand the concept. Now see, look at this diagram and can you tell me the value of acceleration and the tension in the two strings? Now there are two strings T1 and T2 and just apply some common sense. See what we have done before and you should be able to give me the answer of this one straight away. I'll give you 2 minutes to do this in any case.
A is equals to F by M1 plus M2 plus M3.
What about T1 and T2? That is correct. T1 and T2, my dear friends. T1 and T2, my dear friends. T1 and T2, my dear friends. Anyone? Huh? No one with an answer. If you time, don't worry. Yes. I'm waiting for answers, my dear friends. Still waiting. How long should I wait? Huh?
T1 equals to M1F by M1 plus M2 plus M3.
What about T2? T1 is correct. What about T2?
T2 equals to M2 plus M3 F by
Huh?
M1 plus M2 by M3.
T2 is? Try again, try again. Try again, try again.
M2 plus M3. T2 equals to M1 plus M2 into F by M1 plus M2 plus M. That's
That is correct. See, I'll tell you one more way to remember this. I hope everyone has understood to get the value of A, yes or no? Yes or no?
yes, sir.
If you look at, they call it system. If you look at it as a system, this F is actually pulling the entire 3 blocks together. Yes or no? So this F is A multiplied by M1 plus, or A is F multiplied by M1 plus M2 plus M3. Now look at this T2. This T2 is pulling this entire system. Do we understand this?
Yes, sir.
So now you can remember it this way. See, this acceleration is F divided by total mass M1 plus M2 plus M3. That can also be equal to, this T2 is pulling M1 plus M2. So this is equal to T2. Remember, T2 is pulling M1 plus M2. So M1 plus M2. This T1, oops, wrong color. This T1 is pulling what? Is only pulling M1, yes or no? So that will be equal to T upon M1. Now you can get the values of all these things together. Do we understand this? Yes or no?
Yes, sir.
So your T1 will become M1. Oops. T1 will become M1 multiplied by A. See, this entire thing is A. Do we see this? This entire thing is A. And your T2 will become M1 plus M2 multiplied by this entire thing A. Do we understand this, bacha? Then you have the next case that we'll do in the next class because the time is over. So we'll do it in the next class. I sent you a sheet. That sheet has questions. Please solve those questions. The more the number of questions you solve, the better you will become. And remember what I have told you. Please manage your time better in the exam. I'll meet you on Monday with the next lecture. And in that next, we will try to finish this connected bodies once and for all. Take care. Have a nice day, bacha. Bye-bye. God bless you.
Bye, sir.